AI is getting scarily good at understanding language. But here's the thing. Our world isn't just made of text, right? It's filled with images, charts, and tables that tell really crucial parts of the story. So today, we're going to break down a new frontier in AI that aims to bridge that exact gap, teaching models to see not just the words, but the whole multimodal picture.
All right, so here's our game plan. First, we'll talk about this fundamental blind spot that current AI has. Then, we'll introduce the solution that's making waves, called RAG Anything, and we'll really dig into its core tech, the dual graph revolution. After that, we'll see how it actually holds up in the real world, and finally, we'll discuss why this whole thing might just be a brand new paradigm for AI.
First up, let's explore the core problem that RAG Anything was built to solve. And this is a really big one. It gets right to the heart of how AI understands our world.
We've all heard about large language models, right? LLMs? They are incredibly powerful, no doubt. But the thing is, their knowledge is totally static. It's like a snapshot, frozen in time on the day their training data was collected. This creates a gap that just keeps getting bigger and bigger with our fast-moving world. And as we're about to see, this isn't just a problem of being out of date, it's also a problem of texture.
So to fix this problem, some really smart people came up with a technique called Retrieval-Augmented Generation, or RAG. The idea is actually pretty genius. Instead of just relying on its own static memory, the LLM can go out and retrieve fresh, external knowledge on the fly. This totally transforms it into an adaptive, knowledge-aware system. It's a powerful fix, but it opened up a brand new can of worms.
But here's the catch. RAG was this giant leap, for sure. But it hit a wall, a huge blind spot. See, most RAG systems were built on one major and frankly flawed assumption, that all knowledge is just plain text. Because let's be real, our world isn't just a bunch of text files. It's inherently multimodal. I mean, think about it. Financial reports, scientific papers, medical documents. The really juicy stuff, the critical insights, they're often locked away in charts, diagrams, tables, and images. Old RAG systems had to either just throw that information away or try to flatten it into some poor text-based version, losing all the essential context along the way.
And this isn't just some tiny little issue. The researchers who built RAG Anything, they put it perfectly. It's a fundamental misalignment with reality. By ignoring or totally misreading all this non-textual data, AI is missing out on massive chunks of human knowledge, especially in these super complex, document-heavy fields.
So trying to fix this is no easy task. You run into three major technical headaches. First, how on earth do you represent all these different data types, text, images, tables, in one unified way? Second, how do you break down a complex document but still keep the crucial spatial relationships between all the parts? And third, how do you build a system that can actually find and retrieve information across all these different modes?
Okay, so how do you even begin to tackle these massive challenges? Well, that's where RAG Anything comes in. It's a new framework that was designed from the ground up for our messy, multimodal world. The absolute core idea here is to just stop. Stop treating text and images and tables like they live on different planets. Instead, RAG Anything rethinks multimodal content as this huge web of interconnected knowledge. And that right there, that's the big so what moment. It's a true paradigm shift. Because the goal is to create one single unified system for understanding information in all its crazy forms. So you're probably wondering, how does this thing actually work under the hood? Well, the secret sauce is this really elegant and powerful idea that the creators call dual graph construction. Okay, this part is brilliant. Instead of trying to cram everything into one messy box, RAG Anything cleverly builds two separate parallel knowledge graphs. The first one is a cross-modal graph. Think of this like a blueprint of the document. It captures the structure, like how an image connects to its caption or how a table relates to the paragraph next to it. The second one is a more traditional text-based graph, and this one maps out the deep semantic meaning within the text itself.
But here's where the magic happens. The system then takes these two maps and fuses them together using a process called entity alignment. It's kind of like having a road map and a subway map of the same city. Entity alignment finds the same landmarks, like Central Station, on both maps and pins them together. What you end up with is a single, unified master map of the document that captures both its physical structure and its deeper meaning.
So now you've got this incredible supermap, right? And with that, RAG Anything pulls off another trick: cross-modal hybrid retrieval. It doesn't just rely on one search method, it combines two. First, it uses structural navigation, which is like following the roads and subway lines on our map, the explicit connections.
But second, it also uses semantic matching, which finds conceptually similar ideas even if they aren't directly linked. It's like you've got both a detailed street-by-street map and a satellite view that shows you the whole neighborhood. You use both to find exactly what you're looking for.
Okay, so all this theory sounds amazing, right? But the real question is, does it actually work? Does it perform any better? Let's look at the numbers from some pretty tough multimodal benchmarks. So when you look at these performance charts, something really interesting pops out. See, over on the left, with shorter documents, it's pretty good, right on par with the other top models. But watch what happens as you move to the right, as the documents get longer and way more complex. Its advantage just gets bigger and bigger. This is basically proving the core idea. For the really tough, complex stuff, you absolutely need this dual graph architecture. And get this, on documents that are over 100 pages long, that performance gap just explodes to over 13 percentage points. Now, in the world of AI benchmarks, that's not just a win, that is a massive leap forward. It shows this approach absolutely shines exactly where the older methods just fall apart.
And when you line it up against the competition, you can see exactly why. A model like GPT-4o Mini is powerful, yeah, but it just doesn't handle all these different data types uniformly. Then you've got LightRag, which is strong, but it's text only, so it's blind to everything else. And even GraphRag, which does handle images, still treats complex tables and equations like they're just plain text, losing all that vital structural info. RAG Anything is really the first to treat them all like first-class citizens.
All right, let's pull back for a second, because this is about more than just better scores on a benchmark. This is really a foundational shift in how AI can work with information.
You see, the old way of doing things had this huge problem the researchers call architectural fragmentation. Basically, you had to have a separate pipeline for text, another one for images, another one for tables. It was a clunky, inefficient mess. RAG Anything just tackles that problem head-on by creating one unified, consistent framework that handles the whole shebang.
And that really brings us to the core of it all. We're not just talking about a better tool here. This is a whole new way of thinking about information. It changes the game from just processing isolated bits of data to truly understanding a holistic web of interconnected knowledge. It's a perspective that finally starts to mirror how information actually exists in our real world.
And so that leaves us with this one big, exciting question. What new frontiers are going to open up when an AI can read a scientific paper or a financial report, not just for its words, but for the crucial meaning that's baked into its charts, its tables, and its diagrams? What becomes possible when AI can finally, truly see the whole picture?